Ora è il momento del nostro primo Innovation Talk, che è dedicato a The AI Foundry, Powering the Future with High Performance Computing and Mega Scale AI. Allora, finora noi abbiamo parlato di HPC, ma il titolo di questo workshop è dedicato all'intelligenza artificiale, in quanto le esigenze di calcolo devono essere ad alte prestazioni se le dimensioni del problema oppure la necessità di fare molto in fretta devono appunto essere molto grandi, oppure ci sono necessità particolari per trovare soluzioni in tempi brevi. L'addestramento e l'inferenza dell'intelligenza artificiale rientrano proprio in questi due casi. Per fare entrambe le cose su scala massiva è necessario sapere come progettare, come costruire, come gestire un'infrastruttura HPC di grandi dimensioni. Adesso vedo che tanti sono andati a prendere il device per la traduzione simultanea, quindi è possibile che perdano, diciamo, l'inizio del primo speaker. Questo insomma mi dispiace abbastanza. Ciò nonostante, appunto, abbiamo prendo un po' di tempo, i quattro primi relatori, che sono Vik Malyala, President and Managing Director di EMEA SVP Technology and AI di Supermicro, Daniele Cesarini, Project Manager di HPC Technology Specialist di CINECA, Marco Fanizzi, Managing Director Italy di Dell Technologies, Rick Koopman, EMEA Director HPC and AI Emerging Markets di Lenovo, e Giordano Mancini, CTO e 4 Computer Engineering. Allora, io invito, quando chiamerò i relatori uno per uno, quando finiscono di parlare, li invito a sedersi qui, perché poi alla fine del panel voi potrete fare qualche domanda appunto ai relatori. Allora, invito il primo relatore, che è Vik Malyala, che è stato responsabile tecnico e di marketing di prodotto di Broadcom, è un ingegnere progettista senior presso Serverworks, è entrato a far parte di Supermicro nel 2009 e ora è appunto il president e managing director di Supermicro, che è leader tecnologico globale impegnato a fornire innovazioni all'avanguardia per infrastrutture IT aziendali. Purtroppo devo chiamarlo, nel senso, anche se le persone ancora non sono rientrate. Ah, ci sono anche delle sale parallele, vabbè, benissimo. Allora, grazie. So when you finish, if you can sit there. Okay, thank you.
Still morning, so good morning, guys. Thanks for giving me the opportunity here. So before I get started, first of all, I want to thank E4 to give me this honor to be here. Number two, I wanted to take this opportunity to wish happy birthday to my dear friend, Francesco. Come, stand up, man. He's the president for E4, as you know. He looks as young as ever, right? So much energy and everything. So probably something to do with AI, and opportunities come with it. So what I wanted to share is, first of all, with NVIDIA and DDN presenting, I think they kind of give a good picture of where things are. But what we, as in Supermicro, is trying to do is to bring it to you as a solution. And what I am planning to mention is what we are seeing, what we are doing, and what we are expecting the industry to be, and how we can be part of it together. So my name is Vik Malyala. I am from Supermicro. So first of all, when you take a look at what is happening in terms of the AI, the biggest portion is related to how the models are evolving. So everyone talked about like, how large these GPU systems and how converged these things are coming, but mainly it's because of the need to have a way to solve bigger and bigger problems. So that's the first part of it. You are seeing things that are taking trillions of parameters that need to be trained, which requires a lot of infrastructure, which requires a lot of power, which requires a lot of data center space and whatnot. Of course, a lot of money too. But when it comes to the AI and HPC infrastructure, one thing that we are seeing is they are very similar. That is why I think the partners like E4 come into picture, who historically have maintained their leadership in the HPC industry. And that actually translates into what can be done when the complex AI deployments are going to happen. One of the things that we are seeing is today, we are already at 200 kilowatts per rack. And as you have seen from Rod's presentations, I mean, the next ones are going to be what, like 650 kilowatts, and then it's going towards a megawatt per rack. Per rack. I mean, we are talking about how do we bring that power, and how do we cool that, and how do we ensure that everything stays operational. So if it is going to be air-cooled, which is majority of the data centers today are, what are we going to do to accommodate that in those? And what kind of problem sets can make use of air-cooled infrastructure? That's another thing that to be looked at. And when you start looking at these data centers, as I mentioned, majority of the data centers are not quite ready to take advantage of the latest infrastructure, especially coming from NVIDIA and AMD, right? Why is that? Because you take a look at larger and larger, the gigafactories and whatnot, they're fantastic for large deployments. But many of the research institutes, many of the partners that we are working with are actually working on much smaller scale. You're talking about megawatt, 2 megawatt, 5 megawatt kind of data centers. And we need to understand what are the things that are happening in that space and how we can actually go do something about it. So in terms of the data center challenges, you have seen already the processors or the CPUs are going towards like 500 watts per GPU. And sorry, per CPU. But when you take a look at the GPUs are going in the north of like 2,000 watts. Very quickly, it's going to be like 2,500 and 3,000 watts like that. So when you take a look at from the systems point of view, there are certain things that we can do with air-cooled. Beyond that, we do have to shift to liquid cooling. This is the reason we need to kind of start looking at what is that we need to do at a given point of time in terms of what we are trying to do, what is available, and what problem need to be solved. So when we start looking at hotter and hotter elements that need to be cooled, there are a few things that obviously comes to mind. There's only so much heat that can be removed using air. So that's when we need to start looking at liquid cooling. Not every data center is equipped with liquid cooling. So what we are doing, we are putting liquid to air, so which basically do not require, think of like a closed loop liquid cooled solution, where you are able to take even something like a couple of NVIDIA GB300 NVL72, put a sidecar, and be able to run with it without having to worry about retrofitting your entire data center. At the same time, many data centers are a lot more comfortable adopting direct-to-chip liquid cooling, and we are making sure that it stays that way. Last but not least is the immersion cooling, which is fantastic, but it's extremely high in maintenance, and it's going to have its own challenges. For the people who are going to use it, it's great, but majority of them may not adopt. So this is the reason we led with, okay, direct-to-chip liquid cooling is the approach that we are going to take. So if you take a look at today, a GB200 or GB300, which we started deploying right now, these things we are able to provide in two different ways. One is, of course, we can do an in-rack or in-row type of cooling, but the liquid cooling portion, you can have a in-row cooling that can be done using up to like 1.3 megawatt kind of, let's say, CDU, or in-rack up to 250 kilowatts we are able to do. For those who do not have it, as I mentioned, you can have liquid to air, which basically a sidecar. As you start retrofitting your data centers, we also want to make sure that we'll make it easy. I will kind of go into the details a little later, but the idea again here is you can put a liquid-cooled data center very quickly by adding a water tower right outside of the facility, bringing liquid into the data center, and be able to deploy the latest and greatest gear from NVIDIA. So what do we do for that? Besides the GPU platforms, we will be using a lot of compute and a lot of storage in any of the AI infrastructure. This is what we are actually emphasizing. So I want to make sure that we understand every one of the products that physically possible for us to support using air-cooled, we are doing it. But we know efficient way to do that is liquid cooling. So all the compute as well storage and the GPU platforms, to the extent possible, we are enabling liquid cooling. So that's the compute part of it. But then compute part does not go that far. As Paul was mentioning, storage is a very, very critical part of it. We spend so much money on the compute, we need to keep them super busy. So we've been working with partners like DDN to ensure that we are able to bring these solutions to the customers. So depending on what problem size that you are trying to solve, whether it's training or inferencing or HPC, any of it, we are able to provide a solution. And again, you can actually take it and deploy. So one portion is the compute. Second is the storage. That makes networking is an important part. So majority of the deployments that we do are going to be based on NVIDIA reference design, which actually uses Spectrum switches, InfiniBand. Whether you're using InfiniBand or Ethernet, we have all that. But people do like to have choice, especially when it comes to storage, when it comes to different size of clusters. So we do have an opportunity to provide different options. I have seen customers who are using NVIDIA switches, they use Arista, they use Juniper, etc. And for at the top of the rack or some of the smaller deployments, we do have an option from Supermicro based on Broadcom as a silicon, Tomahawk 4 or Tomahawk 5, based on Sonic OS. But when you are putting these things together, the most important thing is the ease of deployment and predictability of performance. This is the reason we go with the reference designs, whether it's based on NVIDIA, whether it's based on AMD. These are the reference designs that we put together, which actually helps people in adopting, whether it's air-cooled or liquid-cooled. Today, you take a look at it, the systems that we are deploying with GB300 and all, they are already actually clocking towards 200 kilowatts per rack. And when you take a look at the networking part of it, which is basically an integral part of building the cluster together. So this is where the reference designs are going to come into picture, and which is where the partners like E4 is going to help. Or if any of your customers are deploying by yourself, we can simply provide the reference designs and be able to help you end-to-end on that part of it. Whether it's going to be NVIDIA-based or AMD-based, we are able to provide those reference designs for you to take from, or we can work with you to see whatever that you need to help with that. And this is where basically a system level, how we transform that at a data center level. We all talked about at a gigascale, but at the same time, at the gigafactories or AI factories, any of these things fundamentally are driven by hardware deployed at scale on which everything else is put in terms of framework, whether it's CUDA-based and then applications running on it, delivering tokens, right? So what you see on the far left is the systems that many of us used to for the longest time. But then came a rack level. In a rack level, we build these systems together and we deliver the solution easily and predictably. Then you do a cluster level. When you go and deploy starting multiple clusters in a data center level, that's where the whole data center building block solution from Supermicro comes into picture. If you take a look at it, it looks rather very simple, right? I mean, you have a bunch of systems, and whether it's AI optimized or cloud or HPC, these are all the rack level solutions that can be put together, which need to be connected to some amount of, let's say, cold plates, the CDUs, CDMs, and be able to connect all the network to match like reference designs from NVIDIA, for example, to put it as a networking. Then you need to look it end-to-end as a project. So what ends up happening is, the animation gone, but bottom line is in every stage, it gets more and more and more complex in terms of delivering the solution. This is where you as the customers and E4 as a partner will come into picture in ensuring that the project get looked at from the very beginning so that the surprises are taken care of and addressed upfront. And that basically gets us to a solution. I think Paul mentioned about XAI as one of the examples. This is the one. Together, we were able to deploy it in 122 days. And this is like 100,000 plus GPUs. Of course, NVIDIA was able to provide the GPUs and be able to support us to ensure that this goes in time. Not every cluster will be at this level, but the idea again here is the way and the pace at which things are moving is incredible. And the one way to do that is to validate the solution and be able to get in front of you, so you will be able to go and run with it. And that is what Supermicro has been doing and investing a lot in that aspect of it. So this is the XAI. But if you take a look at it, this is something that we have deployed even at Intel. This is the air-cooled data center that is running at 1.06 as a PUE. And this is the standard compute platforms. Why I'm mentioning it is not everything need to be liquid-cooled. And when you are taking a platform, either air-cooled or liquid-cooled, standard compute, or with HPC application running on GPUs or otherwise, we are able to provide the right solution and be able to deploy at scale. Whether it's small one, fantastic. The large one, even better. Similarly, when you start looking at system deployment using liquid cooled, it can get quite complex too. And we have done that in a very, very large scale. The point I'm basically getting at is whether it's a small scale or large scale, we need to be able to help customers to adopt it. And sovereign AI is one of the things that we are all talking about. And we started investing a lot more in Europe. This is our brand new facility in Netherlands, which is focusing on building a lot of AI infrastructure, whether it's GB300, whether it's B300 systems, or if you are looking for inferencing applications at a small scale, using RTX, for example, if you're addressing enterprise workloads, all these things can be built right in Europe for the deployment happening in the European Union. So this is one thing that I'm quite happy to share. And why? Because we've been working with the likes of NVIDIA and DDN and others to see what is that we can do to design and develop in time. So when the product is announced, very quickly we can go deploy it. This is absolutely important because, as Rod was mentioning, at every year when NVIDIA is announcing a brand new product, it's 3 to 5 times better than the previous year. So if I am basically taking an NVIDIA product and taking 6 months to go introduce to you, you're already losing 6 months of productivity. That is something that we want to make sure that we address it. So working closely with the partners, that is one thing that we are able to bring. And DCBBS, or the data center building blocks, is what we are heavily emphasizing on, which will help you to design a data center, smaller scale most of the times, because the larger ones know how to do and what to do by themselves, and be able to put these things together and speed up. Not everything need to come from Supermicro, but we can work with you to ensure that you are able to speed up. And we have done first to market and first to deploy these clusters, and it's going to be that way going forward also. And whether it's based on Intel or AMD as a processor that goes into these HGX type of platforms, we have done that, and we have been deploying that with B200 and B300 HGX platforms. And last but not least is that we have worked with NVIDIA to put a launch pad, which basically gives you an ability to play with these GPUs at no cost to you, 0 cost. And NVIDIA actually standing behind this to help, to ensure that they are able to help you to test it, and if you get stuck, to go help with it. So there's a bunch of, I would say, RTX as well as the L40 GPUs that are sitting there. And there are some platforms that are even in Supermicro site, which is great for using for Jumpstart. And this is the reason I think we can really work with you to accelerate whatever the AI initiatives you have, whatever the HPC initiatives that you have, because ultimately products, technology, and solutions, we take the ownership. And we have partners like E4 who can actually help you to do the last mile in terms of deployment, support, and service, which will help you to focus on whatever the research that you are doing, giving you the best-in-class platforms. This is what I wanted to share with you. Thank you.
Grazie, grazie, prego. Può accomodarsi. Allora, cosa significa gestire una AI Factory? CINECA è il maggiore centro di supercalcolo in Italia, uno dei più importanti a livello europeo, che mette a disposizione della comunità scientifica infrastrutture computazionali avanzate. Daniele Cesarini è Project Manager e HPC Technology Specialist di CINECA.
Okay, thank you. And today I will talk to you about Italia. Italia is the Italian AI Factory. It's a project to develop a very large AI supercomputer that we will provide AI services to Italian and European community. Italy, of course, it will be the most powerful AI supercomputer in Italy and one of the most powerful AI supercomputer in Europe and in the world. But just to start, I want to introduce a little bit about CINECA. CINECA is a universities consortium composed by more than 120 members. There are most of the Italian public university, the Ministry of Education and Research, most of the Italian research agency, university hospital, and so on. We have 6 offices, Bologna, Milan, Rome, Naples, Chieti, and now also Palermo. Our headquarters is in Bologna. We are more than 1,000 employees overall, and we have 3 data centers, one in Casalecchio di Reno, which is a small town close to Bologna, the new one in Bologna, where also Leonardo, our pre-exascale system, is installed, and we are starting up a new data center in Naples in collaboration with the National Cybersecurity Agency. We are over than 50 years on the supercomputer ecosystem. We start in the 60s with our first CDC machine, but we also have the first supercomputer in Italy, the first vector machine in Italy, the first parallel system, the first multi-parallel system, very long history in all the Cray supercomputer with the IBM, but today our tier 0 system, so our most powerful supercomputer is Leonardo, which is ranked in the top 10 of the top 500 list. But today I'm here to talk about a little bit of Italia. Italy is this project, AI project, founded by the European Commission to provide AI supercomputer in Europe. In the first round of funding of this project have been awarded 7 projects. With these 7 projects on different countries in Europe, there is also Italia. Italia is composed of in reality, it's composed of 3 country members, which is Italy, of course, and Austria and Slovenia as well. But it's also composed of 26 different entities that support this action. Italia is not only a supercomputer, so an infrastructure, but it's also a services on top of this infrastructure. So we have 2 main brands, the one of the services and the one of the infrastructure. I will talk a little bit now about the services that we will provide on top of this system. Let me say that the services are composed on different levels. On the top we have the user of this AI factory that will be used for AI for science, so this means academia, research center, but also for innovation, so to support the work of startup, SME, industry, and of course for public goods, like to support public administration and so on. We have AI that we call it AI Gate, which is a support on these services, and after that we have the real services. The real services are composed on 4 main branches that we have services related to data, so to all the management and orchestration of the data inside the infrastructure. We have horizontal services that we will provide user support in order to also to orchestrate the workflow inside the system, to optimize the model, to help to deploy model on the factory. We have vertical services that I will talk a little bit in the next slide, which are services specifically for specific community, and after that everything's related on AI skills, so education, training, hackathon, school, internship that we will provide inside of the project. Related to the vertical services, we have 4 main vertical, which are agri-tech and agri-food, led by Fondazione Bruno Kessler and TEF Agri-Food. We have cybersecurity managed by the National Cybersecurity Agency. We have vertical services related to the earth, weather, climate, which is the leader is the Italia Meteo, so the Italian Met Office services, and the manufacturing vertical services that will be managed by Confindustria and the Fondazione EI for EI in Italy. But let's talk now a little bit about the infrastructure. So Italia is an investment of almost 400 million euros in 5 years, provided by 50% of European Commission through the HPC undertaken and 50% from Italy. The capex of the infrastructure, it will be around 300 million euro, which is 2.5 times the capex that we will use to build Leonardo, our per exascale machine. And this will be a quite big machine. We have a power limit in the data center around 80 megawatt, so we will need to feed the system in our data center in this power envelope in order to power up the system. So this will be quite challenge, as the other speaker said about the power that today is needed to run this giant machine. But I want to talk a little bit about our journey on Leonardo. Okay, first of all, we set a goal, and our goal is to reach 10 times the AI performance of Leonardo, of our Tier 0 system that today we have in CINECA. We see that Leonardo is a capacity of AI training of around 10 exaflop, and with Italia, we would like to reach one order of magnitude higher, so a capacity of training of AI of around 100 exaflop. We have we also set a timeline, the RFP, that we have to release in the next days, the next week. We'll try to award the project by the end of the year, signing the contract by the end of the year. We want to start the installation in March 2025 and going up in full production for the first phase of the project, because for power limit of our data center, we will need to split the project in a phase 1 and phase 2. In the phase 1, we want to go in full production between June and December of this year and conclude the second phase between the end of the next year, starting from the end of the next year up to June 2027. After that, to realize this big system, we need a receipt. So we need a receipt for compute, we need a receipt for network, and we need a receipt for storage and also for the data center. Talking a little bit about the receipt of the compute, to realize the systems like this, we should put in production something around 8,000, 10,000 GPUs with an HBM memory capacity of between 1.5 to 2 petabyte, and with a memory performance to support this workload of around 64, 80 petabyte at second of data movement inside the system. This will also mean that this system should compose of around 2,000, 2,500 node with 4 GPUs on it, with a very, very ultra high density rack that can scale between 96, 144 GPUs per rack. That means that we should provide something of around 70 and 100 rack, where each of these rack can consume up 250 kilowatt per rack. About the network, to support this amount and giant computing capacity, we also need a very, very strong network to move data inside the network. So we talk about a network between to connect only exclusively the GPUs, 400 gig for GPUs, and deploy a full FAT3 topologies, so a no blocking unblocking topology to speed up the communication between the GPUs, which is really critical for communication, and a different nord-south network to connect compute to the storage, but also to compute and storage all side of the system, using also a FAT3 network topology with at least 400 GNIC for each node in the system. We are talking something that we should deploy for the east-west network, something around 12,000, 50,000, 800 GNIC, and something around 2,000, 2,500, 800 G-links for the nord-south connection. After that, we need a very big storage to support this. Let me say that we organize the storage in 2 tiers, a fast tier with a connection of this storage very, very close to the node. Inside the node, both tiers will be full-flash technologies. The fast tier will be connected directly inside the node to high throughput, high IOPS, and high bandwidth data movement in order to support the checkpoint and so on, and a big data lake that supported with a parallel file system, but also with the classical storage protocol like NFS, and of course object for to share the data. We will deliver something of around 100 peta of full-flash technology only for the data lake. And if we make some calculation, because the performance of the system is related to the performance of the GPUs, in particular are related to the capacity of the memory that we have. We did a target, so the target for the fast tier is to be able to dump and restore the total memory GPU of the system in less than 2 minutes. And for the data lake, a capacity that to store the total memory of the GPUs is less than 30 minutes, and able to recover everything from the data store in less than 10 minutes. This means that we should have to provide a performance of 15 terabytes second for the fast storage for both reading and writing, and around between 1 and 3 terabytes second on the data lake in order to fulfill this requirement of performance. After that, we will install this system in our data center in Bologna, today in the Dama Technopole, where today is installed Leonardo, our system. Also the data center of ACMWF is located there. Leonardo is in data center in the bottom panel data hall 1. Italia will be installed in the data hall 3, and we should fit everything in a space which is 1/3 smaller than Leonardo 1. So the power density of this data hall will be extremely high with respect to all other systems that we have in the system, that we have in our history. Power consumption, as I said, up to 18 megawatt, that we expect at 10, 12 megawatt in a fully operation the system. The system must be completely in direct liquid cooling technology, otherwise it's not possible to cool down such a big system, with more than 95% of the TDP of the system cooling down using warm water technology, higher than 36 degrees, in order to be efficient as much as possible. With, as I said, in a ultra high density system located in a data hall 2, otherwise impossible to fit 10,000 GPUs in a space which is of 1 tennis court and half. We will release the tender maybe today, maybe tomorrow, maybe the next weeks, and now is in the end of the European Commission, but we are very, very close to release this, so please. Thank you.
Grazie. Prego. Allora, vedere l'impatto dell'intelligenza artificiale generativa e l'impatto dell'intelligenza artificiale agentica nei paesi del mondo è un'opportunità straordinaria. Io ho avuto questa opportunità, quest'anno sono andata a girare un reportage nella zona del Karabakh in Azerbaigian, un'area totalmente devastata da 30 anni di guerra, in cui non è rimasto nulla in piedi, perché anche le pietre dei resti, insomma, che c'erano sono state vendute agli iraniani, con 1.500.000 mine. Ebbene, in pochissimi anni sono riusciti a ricostruire intere città e interi villaggi grazie all'utilizzo dell'agentic AI, che ha dato una accelerazione incredibile a tutta la fase di progettazione, a tutta la fase di organizzazione, diciamo, delle ricostruzioni, perfino nella scelta e classificazione di chi doveva andare a vivere nei villaggi appena ricostruiti in base appunto all'origine della famiglia, se erano quelli che dovevano tornare lì, la distribuzione nella prima fase del rientro di un reddito di cittadinanza, tutta la parte legata appunto al censimento della popolazione, la implementazione di sistemi di sicurezza estremi nei villaggi che si trovano al confine tra Armenia, Azerbaigian e Iran, quindi con sistemi di telecamere, webcam ovunque, con riconoscimento facciale, ma tutto è stato fatto ovviamente con un investimento di 18 miliardi che ha in questo momento l'Azerbaigian, anche grazie alla maggiore vendita dall'inizio della guerra in Ucraina delle loro risorse come il gas e il petrolio, e tutto questo è stato fatto grazie all'agentic AI. Questo per dire poi come le società riescano ad avvalersi immediatamente e noi possiamo fare tesoro di esperienze fatte da altri, speriamo non per ragioni di guerra, ma magari in casi di appunto cambiamento climatico. Ogni tanto sentiamo che ci sono dei disastri anche nei nostri territori, nell'Appennino, oppure appunto se ci sono terremoti, speriamo di no, però comunque sia, diciamo così, vedere questo tipo di utilizzo è molto importante. Vi dico anche che esteticamente questi villaggi ricostruiti da gente che hai non è che proprio siano bellissimi, quindi diciamo c'è anche un lato che un po' fa un po' paura, tipo Black Mirror, però è interessante. Vediamo invece adesso qual è l'impatto dell'AI generativa e dell'agentic AI sul tessuto imprenditoriale italiano con Marco Fanizzi, Managing Director Italy di Dell Technology, che è una multinazionale tecnologica ovviamente che fornisce un'ampia gamma di prodotti e servizi. Salve, può accomodarsi qui. Buongiorno.
So, good morning all. So, it's an honor to be here after my colleagues. And I have also the luxury to switch from English to Italian because so the audience is pretty much Italian and we have great translators over there. I don't know if are agentic AI or real people, but it's good to have them. So, torniamo alla nostra lingua, amata lingua. Mi ritengo una persona fortunata e penso che comunque tutti quanti noi siamo fortunati a essere in questo mondo, in questo business, in questo momento. Sono tornato in Dell Technologies 4 mesi fa e sono tornato a casa, sono tornato nell'azienda che amo, con le persone che comunque stimo, e sono anche tornato nella country che amo, perché ho passato gli ultimi 6 anni in giro per il mondo. E una delle cose che ho notato in giro per il mondo è che nonostante i nostri sforzi e nonostante ci sia un tessuto sociale che comunque sta spingendo e che comunque è innovativo, abbiamo il solito problema di andare at scale, cioè di scalare le nostre aziende. Questa è una cosa piuttosto comune, è una cosa che dà anche piuttosto fastidio in qualche modo. Abbiamo sentito prima diciamo, a colleghi esteri raccontare del nostro good food, ma sottolineare il fatto che ci hanno messo 2 ore arrivare dall'aeroporto a qui. Ora non so se siete stati a Parigi voi, ma normalmente l'aeroporto di Parigi, per andare a Parigi si mettono 3 ore. Il problema è che l'Italia sta rimanendo indietro da un punto di vista dell'investimento tecnologico. Il giorno che sono arrivato qui in Dell, la prima cosa che ho fatto è una QBR quindi una quarterly business review con il team. E la prima cosa che ho visto è che la Dell è cambiata fondamentalmente, cioè l'utilizzo dell'intelligenza artificiale generativa ci permette di guardare le cose e di programmare le cose in una maniera completamente diversa. Poi sono fortunato perché il giorno 3 del mio ritorno in Dell Technologies ho incontrato lui e 4, Cosimo, e nella nostra discussione del terzo giorno mi ha praticamente travolto con la sua passione, la sua competenza e raccontandomi quello che stavano facendo, che avrebbero fatto, che stavano facendo con noi. Poi sono stato, diciamo la settimana dopo ho avuto la fortuna di andare a Las Vegas, al Dell Technology World, dove anche lì hanno, come dire, Dell ha illustrato quello che è il piano industriale, quello che stiamo facendo in quel mondo, e ho anche avuto la fortuna di andare al GTC a Parigi subito dopo. 2 giorni di incontri dove è evidente in tutto quello che sto osservando che la tecnologia probabilmente c'è e non è il problema, soprattutto non è il problema dell'Italia. Ora, quello che come Dell cerchiamo di fare è ascoltare i nostri clienti. Vorrei rimettere un po' di priorità e vorrei un po' rimettere diciamo, i clienti al centro. Esistono 2 velocità. Esiste la tecnologia e il come questa tecnologia può essere implementata e riesce a essere implementata, perché ricordiamoci che esiste un legacy, esistono dei processi, esistono delle procedure, e quindi per fare in modo di scaricare a terra quello che la tecnologia oggi sull'artificial intelligence ti permette, soprattutto in un mondo inferenziale, diventa molto difficile. Esistono poi le 2 velocità del Sud Europa con il Nord Europa e con l'America. Oggi noi notiamo che gli investimenti sia nel privato che nel pubblico dell'Italia, della Spagna, dei paesi comunque diciamo del Sud Europa, ma anche della Germania e della Francia, in realtà sono molto meno importanti di quelli che stanno avvenendo da altre parti del mondo. Quindi esistono 2 velocità, esiste una problematica di collegare i 2 mondi, quello dell'intelligenza artificiale e quello dell'utilizzo dell'intelligenza artificiale. Nei miei frequenti colloqui con CIO, CEO, CTO, il problema più grande è che mi viene detto: guarda, noi stiamo spendendo tanti soldi per fare per fare degli use case, però quando finiamo lo use case ci rendiamo conto che per fare in modo che quello use case abbia un impatto reale, un outcome reale sul mio business, che poi è il motivo per cui tutti quanti noi facciamo quello che facciamo, in realtà i costi di utilizzo di quell'infrastruttura o i costi di implementazione di quell'infrastruttura all'interno della mia infrastruttura globale mi dicono probabilmente non è la cosa giusta. Quindi uno dei temi è probabilmente quello di partire dal perché facciamo le cose, e questo non è cambiato nelle 2 onde di information technology che abbiamo visto negli ultimi 25 anni. Io ho la fortuna o la sfortuna, diciamo, di essere nato parecchi anni fa e di aver visto, di essere ormai nella, diciamo, 4ª decade di lavoro della mia vita, e quindi ho visto tante cose, tra cui l'avvento di internet con all'interno tutte le nuance di cui potremmo stare qua a parlare per ore, e anche l'avvento dell'e-commerce conclamato a tutti durante il Covid come l'essenza che ci ha permesso, oltre che di risparmiare vite, anche di mantenere la nostra economia prospera. Oggi siamo di fronte a un ennesimo cambio di paradigma, quello che è l'intelligenza artificiale, ma ritorniamo a bomba. Qual è il tema? Il tema è dobbiamo lavorare sugli outcome più che sugli use case, cioè cosa mi serve. E devo dire che, e ritorno a quello che ho detto prima, che ho trovato la Dell molto preparata, Dell ha investito su 3 outcomes, uno quello relativo alle vendite, uno quello relativo alla supply chain e uno quello relativo alla customer satisfaction in generale, quindi tutto ciò che è relazione con il cliente, e da lì ha creato all'indietro delle soluzioni, delle strutture che noi oggi utilizziamo internamente. Io non parlerò di tecnologia oggi, perché non ne sono in grado. Ci sono qua persone della nostra organizzazione molto più preparate di me, vedo tra le file Isabella Valente, vedo Peter Barnes, sono 2 persone che gestiscono il nostro business globale data center sia per l'Italia che per il Sud Europa, quindi se c'è qualche domanda potete rivolgerla a loro. Tra l'altro il 14 di ottobre noi abbiamo il Dell Technology Forum, per chi volesse noi spendiamo praticamente 10 ore con 40 workshop con il nostro partner E4, che ringrazio nuovamente sia per l'invito che per la partecipazione al forum, e lì vi potremo raccontare che cosa facciamo noi. Alla fine qual è il nostro punto di vista? Partendo dagli outcome, chiaro che devi creare un'infrastruttura. Noi, la nostra proposition è l'AI Factory, la nostra AI Factory. La nostra AI Factory che non è nient'altro che un end-to-end infrastructure che ci permette di dare al cliente una soluzione in the box, testata, validata, che diciamo può fruire immediatamente, occupandosi esclusivamente delle cose di cui lui si deve occupare. È chiaro che questa, come dicevano i colleghi prima, questa infrastructure deve attingere a dei dati, ma per poter attingere a tutti i dati di un'azienda, soprattutto di un'azienda enterprise che sia public o private, è chiaro che non possiamo replicare tutti i dati. Quindi una delle nostre tecnologie ci permette di creare una sorta di data lake virtuale da cui andare a pescare i dati per far lavorare la nostra intelligenza artificiale. Ora, ci sono 2 elementi fondamentali per noi. Il primo è il tema dell'open ecosystem. Noi non esisteremmo senza la possibilità di fornire ai nostri clienti dei modelli, delle applicazioni, ma soprattutto dei partner, e qui voglio dire, E4 rappresenta diciamo, l'apice in questo specifico verticale, che permettono ai nostri clienti di fare quello che devono fare. E il secondo elemento fondamentale di Dell Technologies, che secondo me è quello che la distingue molto da altre soluzioni, è il tema dei servizi. Nella nostra parte, vi do solo un dato, noi abbiamo in Italia circa 550 persone, di queste 550 persone 150 sono dedicate al post vendita. Ora, il mondo dell'artificial intelligence, se deve diventare inferenziale, deve avere le stesse caratteristiche del mondo del business oggi, con gli stessi RPO, RTO, come li chiamate, come li chiamiamo, come li chiamate. Sta di fatto che devono essere compliant con il business e con il business model. Questo è quello che facciamo noi, cerchiamo di assicurarci che infrastrutture di artificial intelligence siano all'altezza da un punto di vista diciamo delle performance RTO e RPO delle altre piattaforme. Ora, lo facciamo solamente con le AI Factory? No. Perché chiaramente, come avete visto oggi, esistono altri player di mercato con cui noi ci dobbiamo integrare, a volte con cui ci integriamo, a volte forniamo soluzioni diciamo, proprietarie. Quindi che cosa è la nostra, qual è la nostra strategia, qual è la nostra proposizione? È una piattaforma, ci sono piattaforme, è un approccio dove noi riduciamo la complessità, dove diciamo, e prima un collega l'ha citato, il tema del time to market, non possiamo aspettare 2 anni, 3 anni per avere qualcosa di pronto. L'altro tema è at scale. È una cosa che Michael Dell ripete spesso, at scale, perché voglio dire, per avere un business sostenibile, per avere un TCO, bisogna partire con quello che serve e arrivare con quello che serve senza dover rivoluzionare tutto. Quindi questo è un po' il tema dell'at scale. Ho ancora 1 minuto e 35, dovrei quasi farcela. Ora, tutto ciò non può avvenire se una società come Dell Technologies non mettesse sul mercato delle soluzioni, un approccio che sia diciamo, responsabile sia etico. E in tutto questo abbiamo anche visto prima il tema della sovranità. Io non andrò a spendere molte parole su questa parte, c'è una sessione dedicata al nostro forum dove noi vi raccontiamo che cosa vuol dire per noi un approccio etico, un approccio responsabile. In sintesi rimane sempre prima l'uomo e poi la macchina. Mostro questa slide perché è importante anche capire quanto un'azienda investa e se guardiamo gli investimenti degli ultimi tre anni di Dell Technologies, noi abbiamo investito circa 8 miliardi in ricerca e sviluppo, produciamo circa 2.800 brevetti all'anno e come vedete ne abbiamo prodotti 31.000 al Q1 del 2025 che per noi è l'anno scorso per ragioni che poi magari vi spiego. E la cosa interessante che mi ha colpito, non so, è che l'87% dei nostri ingegneri sono focalizzati sullo sviluppo del software. In un'azienda che va end-to-end, dal personal computer fino allo storage, passando per il network, con sicuramente soluzioni server all'avanguardia sia dal punto di vista tradizionale che dal punto di vista delle GPU, è un dato comunque interessante. Ora, mi hanno detto, vabbè, ma porta uno use case, porta un caso. Ora, io ho portato questo caso pur, avendo, una disconnessione tra cuore e cervello, perché come voi potete immaginare, questa cosa che la McLaren ha degli outcome, come vedete là sotto, 90% di riduzione nel design, una produzione di nuovi modelli che praticamente viene fatta in meno di ore, una capacità comunque di raccogliere da 100.000 sensori le informazioni sulle macchine, permette a McLaren di fare quello che fa, quindi l'outcome finale lo vedete bene. È chiaro che al cervello mi fa bene, al cuore un po' meno, essendo io ferrarista da quando avevo i pantaloncini corti, però è importante capire qual è l'impatto nel mondo reale. Ora, io penso che intanto ringrazio nuovamente Quattro perché secondo me questa è una vetrina che ci permette di raccontare le cose da un punto di vista diverso. Spero che l'Italia, questa è anche la mia, uno dei motivi per cui io sono tornato qui, io penso che l'Italia abbia davanti una grandissima opportunità, penso che il fatto che gli investimenti qui siano oggi meno degli investimenti fatti in altri paesi non vuol dire che noi non ritorneremo a fare gli investimenti e probabilmente ne vedremo dal 2025 e sicuramente dal 2026 across the board su tutte le società. Penso anche che, come vi dicevo prima, siamo nel posto giusto al momento giusto. Noi siamo pronti, spero che lo siate anche voi. Ringrazio ancora i Quattro e per chi avrà voglia di ascoltarci ed approfondire ci vediamo al 14 qua a Milano. Grazie.
Allora, è il momento di Vik Koopman, direttore HPC e AI di Lenovo, nella regione EMEA, responsabile dello sviluppo e dell'attuazione della strategia commerciale, della tecnica di vendita e dell'abilitazione dei canali e del campo. Lenovo è una multinazionale cinese che opera nel settore tecnologico, fondata nel 1984.
Okay. Cosimo, thanks for the invitation. Happy to be here. Always a pleasure to be here. I'm going to switch back to English because my Italian is non-existing. So I'm not even going to try it. And reverse engineering that is also not going to work for me. So thanks for the invitation. I want to do it slightly different than what was done up to now. I've tried to take care of the fact that I didn't want to have any of my product slides in there. I didn't want to talk about our servers. I don't want to talk about our implementations. I want to have a few words about the convergence of high-performance computing and the AI landscape. There's a lot of customers that are not only running a big HPC site and not going to build a 10 or 20 or 100 megawatt factory to run AI with a lot of bells and whistles to it. So I want to spend some time on the convergence of HPC and AI and elaborate a little bit on what to look for, what to look at, and what to pay attention for. Certainly, the energy consumption has been mentioned already a number of times. That's, of course, one of the bottlenecks. But it's one of the bottlenecks. It's one of the problem areas you need to address if you want to set up dense AI capabilities in your compute center. Now, I mentioned it already a little bit on the convergence of HPC and AI. And let's start. Now, what are the common elements? You need to start with that. From a common element perspective for both HPC and AI, there's a number of them. And I mentioned the most important ones over here. So you're talking about the accelerators. And that could be GPUs. But for some of our customers, it's not only GPUs, it could be FPGAs also. There's customers that are developing algorithms running on FPGAs and need to deploy FPGA-based clusters to run their algorithms. We're talking about high-speed fabrics. NVIDIA is one of the sponsors here. They have networks both from an InfiniBand low latency perspective to all flavors of Ethernet that you want to deploy. But there's more flavors to the networking capabilities than NVIDIA only, as there are also more capabilities from an accelerator perspective than the current Blackwell generation only. So there's more flavors than that. Top-end CPUs, top-bin CPUs. I'm going to give you a little impression of how everything within a compute node aggregates to your total power connectivity values. And the first time we started doing this a number of years ago, and with a number of years ago, I'm talking about 14, 15 years ago, when we started with the first warm water cooling systems to be delivered already, supercomputers being delivered, completely warm water cooled. So the aggregation of that is, initially when we looked at it, it was pretty shocking. High-speed storage. Well, you've heard about high-speed storage already. High-speed storage also is not only NVMEs, there's also data lakes that are needed, because your hot data is going to be on NVMEs. But once you're done with the hot data in your AI algorithms or HPC computational work, it needs to be moved because it's too expensive to keep it on very expensive and high bandwidth NVMe storage. And what you see increase with the AI era that we're in and moving in further is the deployment of a lot of open source software. Open source software that needs to be deployed on your platforms, open source software that needs to be managed on your platform. But not only that, you also need to take care that you can support it on your platform. Because if you look at the most of the European tenders and RFPs that are coming out, support of the software stack is one of the requirements. Well, I can tell you that's a very interesting exercise if you're talking about all those hundreds and thousands of libraries that you're going to need for an AI environment. So what's needed in both an HPC, but also in an AI environment, on the converge of that, is a scalable, flexible, and shared infrastructure for those sites that are working in an environment like that. Now, where's the convergence happening? So, on an application level, it's happening. So, similar to HPC, AI, is a compute-intensive, very often memory-intensive, high-bandwidth type of workload that's running on your compute infrastructure. And you typically want to fix or address a problem with it. Commonalities between HPC workloads and AI workloads. From a technology perspective, fundamentally, it might be the same building blocks that you're using for both HPC and for AI. That's also what we're seeing with a lot of customer requests coming in. You know, we want to have an environment that's capable of supporting our AI growth expectations or projections, but you know, we also still have, and excuse my French, a shitload of HPC workload that we need to run. Now we want to use, typically want to use that same infrastructure, and no matter if that's NVL4, NVL8, NVL72, or whatever, they need it to be uniform, and they don't need it to be HPC only or AI only. Locality. You know, common HPC infrastructures in typical academic and research institutions, you know, they are extended in their environment to run those workloads and use the data. So from a convergence perspective, the three key areas are applications, technology, and data locality, which you're going to need for your compute platforms. Now, there's also a couple of problem statements. There's a couple of issues that you're confronted with, and issues are there to be addressed and to be fixed in order to get the best possible solution fitting your requirements up and running. So at scale, problems always are increasing dramatically. And no matter if that's compute, if that's networking, if that's storage. Let's go. So evolution, the changes in the technology and the evolution of the technology is, you know, not making our lives easier. It all looks nice in the brochures and on the pictures, but in order to get stuff designed and ready to be deployed at a customer site, there's a lot of things that you run into. Now, one of the things and the problems that you run into is the fact that the TDP values of the components that you're using are increasing dramatically. Processors at the moment, 500 watts. It's not going to stay at 500 watts. That's going to increase dramatically. Yeah? So a little bit of history, 2014, it was 145 watt. At the moment, there is no processor below 200 watts in the current generation. So you have two of those monsters typically in a server, and in one tray, you have two of those nodes. So if you have 36 of those trays, only CPU in one rack, you're talking 72 nodes in one rack, and you're talking already, for simple CPU compute, you're talking about 90 kilowatts. That's only CPUs. We're not talking GPUs. We're talking the increase of memory consumption of CPUs and the commodities around that. Now, from a GPU perspective, that is going even faster than the processors. You know, if you're talking about GPUs now, it is 1200 watts per GPU. You typically have 4 or 8 of those monsters in one server. Memory has to be added to it, which you see over here. Memory used to be noise when calculating the power needed for your HPC or AI server. You didn't have to look at it. It was minimum. For one dual socket node, at the high frequency it's running it now with 24 memory channels, you're aggregating it to 600 watts. That's one server. Add to that the processors. Add to that the network adapters. Because the network adapters now are offloading workload. They're doing computational work in the network adapters. So they're not the stupid network adapters that are noise, like the memory DIMMs are being noise anymore. They are extremely power hungry. And you typically want to have one for each GPU that you have in the server. Now, an additional small problem we see. With the development of processors and the increase of the TDP values, you see another thing happening. And that is that the T-case is getting lower, which basically means that the surface temperature of where you put your cold plates on or where you put your heatsink on has a maximum temperature before it starts disintegrating. And that's not something you want to happen with your processors or your accelerators. You don't want them to disintegrate. So you want to keep the temperature within the boundary. So it's moved down from 85 to 60 degrees Celsius, which is one of the reasons why instead of having skyscrapers on top of your GPUs as cool elements or on your processors, direct water cooling is the only way forward. Now, there's an alternative to water cooling. You can go higher, which are the skyscrapers that you see on the accelerators, which force you to have 8U, 7U, or 8U air-cooled nodes if you do air-cooled nodes, or wider also, to make sure that you have enough airflow going through it. I need to step it up, I see. Now, from a 2-socket server, this typically is what you see from a power consumption perspective, about 1,200 watts. That's the energy it needs to connect. Now, what happens when you start using it? And which causes the problem? That's this. The overhead, those stupid little bloody fans create that are installed in your servers. They're creating an overhead of anywhere between 35 and 40%. So in order to run a very simple 2-socket node of 1,200 watts, you need to provide about 1,600 to 1,700 watts to the node per rack. That's a problem. That's energy spent and used you don't get back. Now, facility challenges we're running into: power. At the moment, a 42U rack is about up to 120 kilowatts with a dense GPU-based solution. If you look at it from a future perspective, and with future, I'm talking about next year, you're talking about 180 kilowatts already, and this is going to grow exponentially. I don't know what the last time is that you talked to your energy provider or your data center co-location site, what the amount of power drops you're going to need per rack to facilitate that. If you're looking at the 180 kilowatt, you're going to need about 8 64 amp power drops per rack to be able to power that. There is not a lot of data centers presently available that can provide and distribute the power over the bus bars in such a way that you can do that. Cooling, hybrid cooling is the least that you need to do. Air cooling and water cooling. Water cooling is the ultimate goal. Now, from a weight perspective, we see another issue popping up, and that's weight. With the current generation, we're crossing the 2,000 kilograms per square meter already. So with the future generation, which is the generation that's coming to market at the end of this year, also in a 42U rack, you're approaching the 2,600 kilograms for a normal 19-inch 42U rack. What's going to happen is that I already am speaking with customers that have a data center floor problem. They can't use a raised floor anymore, and the concrete slab on which the raised floor is installed in that data center cannot carry the weight of 2,600 kilograms with a point distribution. So challenges. Now, that results in systems. That results in systems in existing data centers. That results in systems in new data centers. This is a co-location site you see over here. This customer decided upfront, I want to have everything direct water cooled. If you look at the lowest bar that you see over here, so this system of about slightly over 1,000 GPUs is consuming 1.6 megawatt. Not that bad from a power distribution perspective, from power provisioning perspective. The thing, though, is if these guys would have stuck to the air-cooled proposition they initially looked at, it would have resulted in a system that had twice the size of the footprint, and it would have resulted in a system that would have blown 1.6 megawatt of heat into a data center, which means that you need cooling capacity to compensate for that 1.6 megawatt. So it's not only the fact that you need to connect it to the data center, you also need to cool it, which is a very, very bad influence on your PUE. Now, from a PUE perspective, you're going to about 1.06 with capabilities like this, where air-cooled you would typically be on a 1.06, 1.07, 1.6 to 1.7. So improvement all over the place. Key driver is going to be water cooling where possible, because it helps you with the operational side of your system. Have a good look at what you're planning to do. Have a good look at your planning, because it has happened very often already that we came into a customer site and that at the end of the line, things like power distribution over the data center had to be fixed in hindsight. So, thank you very much. And that was it. And there was not one Lenovo server in there.
Grazie. Allora adesso è il momento dei padroni di casa. Come sappiamo E4 è divisa in 5 teams, c'è appunto la Tech Factory, Operations, Support, EU Projects e AI Analytics. E allora adesso abbiamo Giordano Mancini, che è CTO di E4, ma è anche il responsabile del team Tech Factory.
Allora, buongiorno a tutti. Solamente 2 parole di conclusione. Solamente 2 minuti, quindi vi separano dal vostro meritato caffè. Intanto grazie ai nostri ospiti e ai nostri sponsor per averci aiutato a creare questo evento, anche quest'anno incredibile. Solamente 2 riflessioni. La prima, Cosimo prima ci ha detto che il futuro va costruito, ma come lo costruiamo? E qual è il ruolo di E4 nella costruzione di questo futuro, di una realtà come E4? Quale mattone portiamo? Beh, possiamo provare a capirlo guardando tutte le tecnologie che ci sono state mostrate oggi e il loro effetto. Come dire, il take home message direi che è uno sostanzialmente. Come si dice? Quantity becomes quality. Le AI Factory integrano quello che era il mondo dell'HPC, ma la complessità che creano è completamente diversa. L'HPC serviva a comprendere, l'AI serve a decidere, e in questo avrà un impatto estremamente più pervasivo rispetto a quello che era l'HPC. E dal punto di vista tecnologico, dal punto di vista del ferro, del silicio, abbiamo visto come questi oggetti siano enormi, la quantità di energia che richiedono, la loro densità di energia è qualcosa di completamente diverso da quello che c'era prima. La loro presenza sul territorio già di per sé crea un impatto geografico locale, perché non la puoi costruire dove vuoi e ciascuna di queste factory poi sarà diversa per come l'andrai a costruire. E quindi quello che porta E4 con la giusta dose di umiltà, ma anche direi un pizzico di incoscienza, è usare l'esperienza che abbiamo accumulato in 20 anni in operazioni sempre più complesse, nel realizzare cluster e infrastrutture completamente diverse tra di loro, da piccoli a grandi, cluster realizzati anche in posti, diciamo, in cui in genere non si pensa a un'infrastruttura HPC, come la cima di un vulcano, alle Canarie, e usare questa esperienza per ascoltare i clienti, ascoltare i nostri partner, direi, nel realizzare il loro progetto. Se le AI, facendo, come dire, una metafora da italiano, è quello che ci possiamo fare è una sinfonia, noi non abbiamo l'ambizione di essere i musicisti e i compositori, ma vogliamo costruire il violino, o se non suonate il violino preferite l'oboe, vogliamo costruire l'oboe, vogliamo decidere con voi qual è il legno che volete usare, l'ottone che volete usare, e alla fine quindi creare questa sinfonia. E credo che da questo punto di vista sia in effetti, come dire, una realtà abbastanza rara, se non unica, in Italia e in Europa. E ho finito, a un secondo dalla fine.
Tenga pure il microfono, così ve lo passate Volevamo appunto sapere se ci sono delle domande. Are there questions for some of them? You can raise hands. I know that you are thinking about the coffee, but I guess there will be some questions. If you're all shy, I start. That is worse for you. Okay, no questions. So I start with Mr. Koopman. HPC and AI share many common elements. There are also differences that will stay, or do foresee any coming with future technology?
So,
take your microphone, please.
So the question is if I see changes growing between AI and HPC.
Yes.
Yes, we
they
will.
Stay split, or they will integrate?
From a convergence perspective, there's still commonalities between the platforms that you can be using for HPC and AI. Of course, with the increase of the computational power of the GPUs and the different way of doing the computational work from a precision perspective, HPC typically is floating point 64 from an accuracy perspective, where you now see already AI inference being very low from a precision perspective in floating point 8 calculations or 4 calculations even. So that is an indication of the exactness of the computational work between HPC and AI that you see happening. I think that my view is that difference will be bigger, will become bigger, because the floating point 4 will become floating point 2, and it is the algorithms that basically determine that 1 + 1 is going to be 2 instead of 1 + 1 could be 2 when you have inefficiencies in your computational work. So differences will increase.
Questions? No questions? Okay. Cesarini, will Italia use artificial intelligence for itself, the system I mean, for itself, meaning using AI to predict problems, anomalies, and so on? What are the main challenges in reaching an excellence efficiency?
Okay, the direct answer is yes. In reality, we are doing right now, not only with the Italian, but with all other systems, in particular to improve the efficiency of our data center. So the point is that AI for the system is something that in order to optimize the power consumption inside the system, inside the data center, it will become crucial in the next year. In particular, as Rick's show that with this big increase of power consumption related to the silicon technology that today is still on encounter some physical wall related to the miniaturization of the component of the transistor, is becoming much more efficiency in terms not only of the system itself, not only of the technology that are employing the system, but also how to use the system. It will become keys. It's keys to this. In Italia, we will, for sure, we will be apply also all the technique, all our past experience that we use, that we gather with our current system, in order to collect data, analyze data through artificial intelligence, and realizing a feedback loop with the interaction of the data center in order to spin up, spin down the the power of the system when this is not fully utilized, because a system like Italia, but also a typical HPC system, is not only used at 100% of the time. So there are phase of the training or inference that are is not need the full power of the system, and so also the full capacity to cool down the system. This is possible to be reduced in order to save energy, and also to optimize the utilization of the performance of the system in order to improve the overall energy efficiency of the system. So the answer, as I said, is yes. Is not easy task, even because the amount of the data coming from the system is giant, because we can collect millions or even billions of parameters in a system like this, and correlate all of them, analyze all of them to extract information in order to optimize the system is not an easy task to do. And today is almost possible using artificial intelligence or data that use this data. And so we need Italia for sure. It will be in a feedback loop that the system that will optimize itself, collecting data from itself, analyzing data, and apply strategy to the system and to the data center in order to improve the efficiency. Is something that today is a reality, but with Italia is not only be a reality, it will be mandatory.
Okay, thank you. Fanizzi, today there is a lot of talk about sovereignty. Also, we talked about before sovereignty, cloud, and edge computing. That is something that the mass didn't understand yet very well, but here, as we are all a little bit nerd, we understand. How does Dell position itself in this balance between centralization and data distribution?
But listen, so first of all, I think that they have to wait a lot of time to have a coffee, considering the type of question. So edge computing, in a nutshell, with the 5G, the capability to have intelligence far from the data center, and so avoid to have a difference between the decision that at the end you have to make. A great example is autonomous driving. So you cannot wait that the latency can be in a range where the car has not to wait to talk with somewhere far to decide if they have to go right or left. And so a good example is autonomous driving. For us, the balance between private and let me say public cloud, or so we are working since years in developing capabilities that are able to give us the possibility to provide to customers private stuff in their data centers, following the local laws and local legislation. In Italy we have Agid, that is pretty much driving everything. But we are also having a sort of co-petition approach, having our infrastructure in a private way placed in a private cloud, in a public cloud with the hyperscaler. So our point is we would like to have to give to the customers choices. They have to choose with us. They need to have the capability to go right and left, depending on their needs, the localization, the country, and the type of business that they do normally. So I think that this is driven by not only the investment that we are doing in terms of research and development that you saw before, 8 billion in the last 3 years, but also in the investment that we are doing in software, startup, ecosystem. So Dell is really double betting on this specific topic.
Thank you. Malyala, Supermicro has become central to the infrastructure for generative AI. And now, for agentic AI, what is your vision at the transition from one to the other?
So I think all our panelists were kind of getting to one thing, which is infrastructure is relatively the easy part. Because if you take a look at NVIDIA and others, they have been providing GPUs that can be used at different scale, whether it's a training or inferencing, whether it's a large clusters that will be based on like a GB or the Blackwell series right now, or the PCIe cards. What I have seen is when I take a look at how it's going to be consumed at the other end, there is a lot of gap. Customers have an existing data flow that they have been using and they're comfortable with, and they don't need to rediscover anything unless it's absolutely forced to. But at the same time, everyone knows that if you don't follow that, if you don't take advantage of the benefits of what agentic AI and other things are going to help them, they will fall behind in the business side. So what ends up happening is as we start providing like speeds and feeds to customers, they don't know what to do with it. And their problem is basically, how do I basically take advantage of this technology? One thing that we have done is working with the likes of NVIDIA on the blueprints. So effectively what ends up happening is, depending on what kind of a vertical that one is trying to use these solutions for, what kind of a GPU or an accelerator, and what is the size of that platform should look like, and what is the framework that we need to put on it in order for them to go and easily deploy. If you remember, last year, the year before, NVIDIA introduced NVAIE. Great, but it's not good enough for the people to take it. That's why this whole thing came about. Then, the advantage of this mixture of experts, that when it came in, it became easier for people to port these applications on a smaller infrastructure to be able to still go and utilize these things. So my take is, maybe in a convoluted way, but the way I see it is going to be based on similar infrastructure. The framework is going to be a little bit different based on what problem we are trying to solve. And we need to put together a kind of let's say, a blueprint on adopting this, making the adoption easy for customers so people can take advantage of agentic AI a lot more than what it is by looking at the books and presentations.
Grazie, thank you. Giordano Mancini, abbiamo detto che appunto il quantum può essere l'opportunità per l'Italia e per l'Europa comunque di raggiungere o comunque di essere più presente in termini sovrani nel mondo appunto del digitale, ma l'intelligenza sul fronte intelligenza artificiale, diciamo, rinunciamo a priori a raggiungere vette come quelle espresse dalla Cina o dagli Stati Uniti?
Beh, è una domanda abbastanza complessa. Direi che quello che sta facendo la Commissione e che quindi farà l'Europa, con attori come il CINECA e altri, indica di no. Quindi c'è la volontà di competere e ci sono anche realtà europee che ci dimostrano che questo è possibile. Mistral, ad esempio. Direi che, vista da italiani, è anche un problema di rappresentazione e di coscienza. Marco prima ha detto c'è un problema degli investimenti. Il problema degli investimenti sicuramente c'è, il problema della scala sicuramente c'è, ma è anche un problema di rappresentazione. Se guardiamo, allora, oggi, diciamo, per rompere il ghiaccio, due ospiti hanno parlato del cibo italiano. Bello, ci fa piacere, ma è anche merito del microclima. Ma se noi chiediamo agli italiani presenti in questa sala la classifica delle prime 5 nazioni che hanno messo un satellite in orbita, quanti risponderanno qual è la posizione dell'Italia? È prima di tutto un problema di rappresentazione. Le competenze e i mezzi ci sono.
Bene, grazie. Se nessuno intanto ha elaborato una domanda, chiudiamo. Eccola, è arrivata. In corner.
Good afternoon. Very interesting, actually, discussion. Hussein from CSCS Lugano. So Rod, in his presentation, talked a lot about these new AI factories that are coming in Europe. And we talked about a really enormous number. We already announced one, actually, in Switzerland. So the growing of these AI factories we are talking about here, the power use, system density are becoming one. The growing, the power use and density is becoming very challenging, really. And we are going in towards a huge dimension. So what solution in hardware, in cooling, and in design do we need to implement to make these large-scale AI factories sustainable at the long term? Thank you.
Is under an RFP.
Can I start here? So one thing that I have seen is people always talk about standardization. Standardization makes things affordable and easy to deploy, and you can get from multiple sources and whatnot. But what we are seeing is, by the time the standards are defined, the game is changing. You have seen, 80 to 100 kilowatts last year, and today, if you take a look at GB 200 and 300, we are talking about 130 kilowatts. Next year, 260. The year after, 650. And Google announced that they are going to talk in 2026 end or 27 beginning. They're talking about 1 megawatt per rack. So if you're talking about designing a data center, thinking that, okay, traditional way of doing things is I'm going to run these many, let's say drops per row, and this is how I'm going to do the cooling and all, it's not going to work. That is the reason that traditional data centers are not going to scale with what is needed. And when you start talking about these large-scale data centers, they are built from scratch to give the flexibility to give sufficient power in a modular way. So what is happening is, earlier, if you build a data center, 20 to 30 years, the data center, nobody asks any question, it's going to run. But if someone says, I'm going to build this data center that's going to be for the next 30 years, I think they should get their head checked. It's not going to work. So what I have seen is modular data centers is one thing that people are going with, if they want to quickly bring it up, because it's taking 2 to 3 years for people to build a typical data center. So modular data center is one thing. Other is, people are looking at, in terms of bringing the liquid cooling and whatnot, traditional way of, there are two ways to do it. You can do in-rack cooling, which basically, depending on what is that you need to bring, you can bring like 100 kilowatt, 250 kilowatt type of CDUs. But as 600, 700 kilowatts per rack is coming, in-rack CDUs may not going to work. So in a heterogeneous environment, we have to plan, which basically means facility level liquid cooling need to come in with different type of distributors to bring different flow rates, different type of temperature that the water need to come in order for them to cool it. And the second thing, which you don't have to worry, but others need to may worry, is the condensation. If it gets too hot, too cold, if it's in a different region, how do you deal with it? Especially when it comes to servicing. Because when things are running, it's going to run fine. Any of the vapor or anything comes, it gets burnt because the GPUs are running hot. What if you need to service it and the GPU cools down? Then there's a condensation. So there are different types of things that are going to come into picture. But short answer would be that you need to figure out a way to bring a data center level cooling that can be adjusted at a rack level as needed. Second, the amount of power that you need to bring in. Today, it's all about power supplies in most of the systems. It's all going to be power rail based as you start looking at a higher density. And within that, how much power that you can bring, how many zones that you can create, both in terms of cooling and power, as well as if some things were to fail, how are you going to minimize the blast radius? These are the type of things that you need to consider to ensure that you are designing something that's going to take advantage of whatever might come, not just now, but a year later and whatnot.
Grazie.
Let me turn.
We are closing to just a few seconds.
Yeah. So just a few seconds. It is a lot of flexibility and modularity that you're going to need, but there's a third element to it. And that third element depends a little bit on the country where you're in. So there is a reason why there's so many sites being developed at this moment in the Nordics. So in Norway, in Finland, in Sweden, the reason for that is that all the energy there is created with water energy. So they're talking about a cost of 4 to 5 cents per kilowatt hour, which is slightly different over here. So it's not only the fact that you need to be able to provide that power to your data center, but you also have to be able to afford it.
Grazie, siamo proprio in chiusura.
Just two words. So the topic we discussed before at scale is valid for everything. And answering to the colleague here, or supporting the colleague, this is why Alaska is so interesting in this moment.
Grazie. Grazie ai nostri relatori che possono riaccomodarsi in platea.